All right. I think there are still a couple folks from core that might come in, but we can just get started here. All right. Let's see. I only saw one new PR this week, and that was from me uh, regarding changing some of our documentation to be slightly more updated than it used to be. Uh, this is just regarding recommendations for CPUs and memory on the OSD side. Um, Previously, we were recommending 1 GB of memory per terabyte of hard drive space, and that was confusing some folks. So I changed that to be kind of more in line with what we see in Blue Store. Let's see. Next on the list, we've got a bunch of stuff closed. The big one here, well, two big ones here, were the IO U-ring support. Kifu merged that a couple days ago. And then also Igor's work on, I guess, a framework for letting you more intelligently use the database space in Blue Store. So not doing kind of what we currently do, where once you start compacting stuff to the block device instead of the database device, it just kind of sticks around there forever and doesn't ever move back. So that's good. I think Adam maybe has a PR based on that actually does smart stuff, but I don't think there's been any progress on that. But maybe there will be now. So that's good. The VLA PR that is being closed in favor of a potentially future PR doing the same thing, but I think he was running into some bugs during testing, and he wants to, I guess, properly test it before submitting a new PR. So hopefully we see that again soon. I've got an op tracker PR that got closed by the Stalebot. That PR was somewhat contentious because it moved the interface away from string view back to C-string. In some cases with string view, when you're trying to store data, it isn't quite as nice, but we could kind of refactor that whole thing in a saner way to kind of get rid of the mixed way that we kind of categorize stuff. So the gist of it is that we could do the whole thing better, but it'll be more work and needs to be done a little bit differently than that PR did it. That PR does include kind of an interesting optimization for how we store and process events too, but maybe that should be handled as a separate PR as well. There's one of those closed by a Stalebot here from Ma Jianpeng. Oh, that was the disabled op tracker by default. I think we determined that we don't want to do that, so that's fine. 2 PRs were updated. This one from Ma Jianpeng for the finisher that was buggy in testing, and I think it's been updated and probably needs to be retested again. And then this one from Eric that does better filtering in CLS for bucket listing. It does basically just reduces the amount of data that needs to be sent over the wire by pre-filtering it in the OSD. I believe he now has that in testing. So that's basically it for stuff that's been updated. Yeah, not a whole lot of other interesting stuff here this week that I see. All right, anything I missed? Any PRs people want to talk about? All right. Well, let's move on then to NVDIM testing, or not NVDIM, but testing toward an NVDIM future. So we talked a lot about this last week. I think we kind of zeroed in on the PG log as potentially being a good use case for NVDIMs. We had a follow-up discussion in an internal meeting about kind of things that we could look at right now without NVDIMS to see kind of what might make sense. And as a result of that meeting, I decided to go and run through some tests looking at both ripping the pglog OMAP rights out of the OMAP rights out of pglog, and then also just kind of more or less disabling pglog entirely, so the in-memory as well. And I tried to look at a couple of different configurations that we know improve performance over kind of the base configuration, at least in this kind of a test. One is to increase the memory target so that you're not doing any kind of reads of OMAP entries during writes. And then the second, I guess, isn't known, but it was suspected to possibly improve throughput when we have pglog no longer writing stuff out. Smaller write-ahead log buffers in RocksDB, so that hopefully we have less work to do there. So the result of that is in the Etherpad. Let me provide a link. It is right here. And so the gist of it is that it's kind of an incremental improvement each time. Getting the OMAP rights out of RocksDB helps, and then totally getting rid of pglog rights and trims in general helps even more. The improvement was not quite as dramatic as it could have been. I mean, it's decent. It's like, I think around 20%, if I remember right, when looking at kind of the optimized kind of configuration versus the base configuration. Or sorry, when you're looking at the master versus the no pglog configuration in kind of any of those cases, roughly. But the big thing that I thought was very interesting is the reduction in tail latency. It's pretty dramatic. We go from like above 60 milliseconds at 99 percentile and the 99th percentile down to like 20 to 25, kind of, depending on which configuration you're looking at exactly. So that was really nice to see. That kind of a pretty big effect on a big cluster, I think. As you'd expect, the amount of time we spend in compaction goes down. It looks like it's higher with the optimized configurations, but that's just because we're actually writing out more data. We're faster, so we spend more time in compaction. But the reduction over the configuration where we are actually doing pglog writes is still pretty dramatic. Let's see, what else? We don't see, or at least I didn't see, a real dramatic reduction in CPU usage, which is a little interesting because when we tested memstore about a year, maybe 2 years ago, something like that, it didn't have a whole lot of improvement on performance, but we saw a big reduction in CPU usage of half. So here we're not. We're spending more time doing other stuff in BlueStore, whereas memstore is apparently not doing nearly as much. So pglog was probably a much bigger fraction of the time spent. Do see kind of what you'd expect to see in terms of an IOPS per core improvement, just based on the fact that the core usage was around the same, but throughput was higher. So that's basically it for now. I'm going to also, I'm in the process of rerunning these tests on our Officinalis nodes. I did notice that throughput on those nodes was lower than I expect. I think something merged to master in the last month that is hurting us a little bit. So I probably am going to be busy doing a little bit of bisection to see if I can figure out what that is, or if it's real. But then I'll run some of these on the new nodes, and also probably some multi-OSD tests, just to see if that reduction in latency is helping significantly when you have replication. So that's it for now. Any questions or comments on any of that?
think it's interesting that you see a similar reduction when you remove the pglog code as well from memory, in addition to removing from disk in the CPU efficiency there. Suggests that there's potential for optimization in the pglog
Sorry,
code
Josh,
itself.
I can't understand what you're saying.
Is that better?
Much better.
Okay, sorry, I moved the mic. I was saying that that you see the efficiency improvement in CPU usage, both moving it away from off the disk and then again moving it into memory or eliminating the memory operations. Pretty interesting. It suggests that there's perhaps a significant when we can get this optimization of the pglog code even without a hardware change.
Yeah, I think so. Interesting though that it didn't really affect the latency at all. Like once you get rid of the PG or the OMAP writes, the or I guess the average latency still goes down, but the 99th percentile latency, it doesn't really have that dramatic of an effect. It seems
Yeah, I guess
the
that
ping
kind of
drum.
matches with it doing a relatively constant amount of work, but
Yeah,
doing a lot more
exactly.
work.
Yeah,
What
I
was
still find it really interesting. Oh, go ahead. Yeah.
I guess it'd be interesting to, what was the size of the data set roughly that ended up in this case?
The overall data set in FIO is 512 gigabytes
Okay.
and one OSD. So it was enough to, with 4 gigs of memory target, an OSD memory target of 4 gigs, we were hitting the database for reads. But when you bump it up to 8, that's enough to basically keep everything in cache.
Right. I guess it might be interesting to do to try like an RGW workload where you would have a lot of OMAP as well.
Yep, I agree. That was the one of the other things I was thinking of trying to do here soon is run hsbench and see what we see in that case.
But to be fair, I mean, I think if you find a dramatic improvement in any of these areas, then probably we're relevant. Reduction in compaction is intrinsically relevant versus like it's additional benefit performance coming over time, right? As you don't pay those. But I think, and I don't think you can make every fully capture the benefit of each of these kind of point changes by off the top line necessarily. But as you remove things from the stack, you'll collect them later. I think you've proved the benefit of this, even if it hasn't even if you haven't hit a massive payoff in all the performance measures you have. Probably shown that it's worth doing this.
Yeah, I think so. And even at that, I mean, it's a decent gain, right? I mean, like 20% at this point when we're talking, going from 45,000 IOPS to 55,000 IOPS. That's
plus compactions you don't pay for later. Yeah, that's pretty significant.
Yeah.
Mark, I'm curious, do you have any like record results for any of these runs? We could see what the pglog in memory versus not is doing.
Yes, I do have some wall clock profiles. Another thing I need to go back and figure out with the bisect is for some reason now in master, I can very easily stall the OSD when trying to do a wall clock profile. It just like totally breaks and then doesn't respond to requests anymore. So it's harder to get, but let me see if I can paste something. It might take a little bit, so feel free to.
Yeah, it doesn't have to be right now, but at some point it'd be interesting to take a look at.
Yeah, what I did see, I can say is even when we got the OMAP rights out, I still saw in each TPOSD TP thread at least 2% of the time spent in log operation doing trim. So that trim workload definitely was impactful. And I also saw that initially I wasn't, I was still adding to the, what do we call it? Not the feature log, something along those lines. The projected log. So we add to the projected log, and then we also trim that in log operation. And I saw an incremental jump when I realized I needed to get rid of the projected log add line, which is somewhere in primary log pg.cc. So basically, all this stuff, the PG log, the projected log, both adding and trimming, all of that work adds to it.
Yeah, certainly. I guess it might be worth considering using a simpler structure for the projected log.
Yeah. I suspect that, individually that might, get you a couple percent. You get a couple more percent from PG log, depending on, how much you shave off by making it simpler, maybe significant, may not be. Josh, what do you think about how do you think we should approach the no OMAP piece of this? Rather than the no PG log test, that's fun, but it's not super realistic. But the OMAP piece, maybe we can we reasonably move this over to some other kind of Blue Store, on disk format? Is that something we should think about right now, like a new interface for that, or using the same interface and just like hijacking it?
Yeah, I think it's certainly worth considering.
You can just write it directly to the object data, right? Create a new PG log object and write directly to that.
Yep.
Mm-hmm.
Sam, would you suggest like continuing to use the same OMAP interface, or
No.
do something?
Just use the right interface.
Oh, I see. Okay.
Yeah, I think that would be an interesting experiment to see how much difference that makes. I would expect a lot lower CPU usage in that case. The same kind of gain that we see with removing the OMAP calls or add persistent storage.
Sam and Josh, you think per PG appends kind of to separate objects?
Yeah, you want each PG to have its own objects.
Yeah.
And probably to a sequence of increasing like numbered objects. You just delete them behind as you trim.
Sure.
It's also maybe worth pointing out that these objects aren't going to be tremendous, so you might even be able to get away with at some point like that, just using maybe two objects and switching back and forth when you want to trim instead of trying to do something more complex with partial rewrites.
Oh, I mean, yeah, you could do that too. That actually strikes me as harder, but either way. This is the way pglog worked before 2012, or so.
What were the downsides of that when we used to do it that way?
It was complicated. We also needed to keep track of the offsets within the output. So the PG info needed to track, well, the PG info as well as each PG log entry needed to keep track of the on-disk offset, if you will. It was error prone.
Sure.
I think it could be relatively more simple than that though at this point, since it's only read on startup. If you did an
Yeah,
append
but
only structure.
when you get rid of divergent entries, you have to know where they are. Right.
That's true.
That
But at
was
that
the
point,
reason for the
we
offset.
might be able to rewrite just the last object or even the entire log since it's relatively small.
I don't think you can rewrite the whole log during pairing. I also don't think it's that hard to keep the offset. It's just extra code.
Yeah.
Sorry, I'm just thinking about it, trying to think if there's any ways to kind of make that process less complicated. Well, in any event, I guess at least there's interesting possibilities here.
Yeah, certainly. I think this shows it's worth exploring. And it'll help Crimson as well, since it'll have the same problem.
Yeah. Sam, is there anything that I can be looking at using your LTTNG work in terms of like latency and where we're spending time in both cases?
No, that's all Bluester level, so it'll just tell you that sometimes submission to RocksDB takes longer, but you already know that.
Yeah, okay.
Might
Although,
be.
what
I
about
wonder if it'd be worth like writing a little micro benchmark for the PG log code that just acts like an OSD does, like adding entries and then trimming, just to see where the CPU usage is spent there.
Josh, are you thinking micro benchmark to test the potential implementations that we could do, or micro benchmark to see how the PG log code itself is behaving?
Well, I guess both might be useful.
Okay,
I think the former for the CPU problem and the latter for the RocksDB movement problem.
sure. I mean, one thing I guess is with PG log, right? It's not just nice, convenient ring buffers per PG. There's all kinds of like zippering and stuff, right?
Yeah, that's what Sam was mentioning about with the divergent entry removal and merging. I'm not
Yeah.
convinced that it's
So
going to be that expensive to rewrite it during peering either, since we were already writing the logs from other peers, but it's worth checking, I guess.
Yeah, but in the common case where an OSD just went down briefly and came right back up, for the trim operation, you're just removing a couple of OMAP keys, and that's a common case. So I don't think you want to pessimize that case by making it rewrite the whole log.
You wouldn't have divergent entries in that case either, would you?
Sure you would. If you have 3 OSDs and you take primary down, the primary almost always has divergent entries, right? Because the other two don't have them. If they went active afterwards, that is.
Yeah.
But I think a small number of divergent entries for small flaps is very common.
Yeah, I agree. Small flaps are common. I guess divergent entries. I'd be interested to see, like maybe measure that and see in practice whether it is showing up all the time or not. But I think overall, like, we're in agreement that the idea of moving this out of RocksDB makes sense, and it looks like it shows significant improvements here.
Sam, if we adopted your idea, that would essentially turn the writing during normal operation into just like straight ring buffer type operations, like just spends.
Yeah, that's the idea.
And we do the work during period instead. How, Sam, how
No,
bad
you don't do
do
the
you
work
think
during
that?
querying either. It's basically the same thing.
Oh.
What?
Oh.
Why would there be more work? There's only more work if you choose to write out the whole log, which I don't think you have to do.
Okay. I'm confused then. I'm not understanding something right.
I guess that would be a simple way to prototype this if you wanted to avoid the extra complexity. That is, you could, since you're not worried about the recovery case in your initial testing, you could just do the append only, not even and trim from the back, and not worry about the divergent entries or anything else, since you're not actually doing a recovery or peering in your performance test. Just looking at the right path.
Okay, cool. All right, well, that's basically all I've got. Anyone want to talk about anything else, or talk about this more, or what do folks want to do? All right. Well, I think we've probably beat this for now. I will continue to run tests. I think Josh, I will look at the RGW case just to see, because I think that'll be interesting. And then I also want to track down what this regression I think I'm seeing is on the official before maybe running further tests there. I'm a little afraid it might be the work that we did on pinning in the BlueStore node cache, but we'll see. But yeah, hopefully next week I'll have some more data on this, and then maybe we can start prototyping something.
Sounds good.
Cool. All right. Well, then have a good week, guys. And let's see. Do we technically? Yeah, we do still have stuff next week, and then after that we'll be off. So have a good week. We'll see you next week, guys.
See you next week.
All right. Thanks.